Huh. Well, look at that. A Geico landed on my lesson plan. Okay. Hey, little fella. How's it going? Yeah? Okay, good. Okay, well, we can work with that. Let me get this fixed. There we go. Let's do some auto focusing. There we go. Hi. Okay, oh, he's smiling. Okay, we'll just move him out of the way. All right, I'll tell you what, last Friday, you found trig ratios given another trig ratio. And we looked at all four quadrants, so we had to be very careful with the sign, S-I-G-N, positive or negative. And our hypotenuse was anything. Here our hypotenuse was 85. Here our hypotenuse was 85, coincidentally. Okay. Today we're going to do something very similar. We're going to use the Pythagorean theorem, but for all of the problems today, the hypotenuse is going to be 1. Okay. Now when your hypotenuse is 1, you're actually working on a thing called the unit circle. Okay, the unit circle has a radius of 1. It's like this. It's like we're on the coordinate axes, but we're looking at the circle with a radius of 1. So we're looking at that circle right there with a radius of 1. So here's the blow up of that inset. Okay, now if our radius is 1, then this point right here would be the point 1, 0. This point would be the point 0, 1. This point would be negative 1, 0. And this point down here would be 0, negative 1. Okay, so we're going to be working with triangles. For example, we're going to be working with triangles. Let's just say it's in the first quadrant. Then we're going to have a triangle. Since the radius is 1, okay, here's another radius. All of the whole radius of this circle is 1. So the hypotenuse is going to be 1. What they're going to do is give us one leg length, and we find the other leg length based upon the hypotenuse or radius equaling 1. Okay, and that's what's called the unit circle, when your radius is 1. Okay, let's look at what the problems look like. Find coordinates on the unit circle. Again, the unit circle has a radius of 1. Okay, let's just go ahead and do this. I'm going to grab a marker. There we go. Okay, so they're going to tell us the point P, x comma negative 5, 6, lies on the unit circle shown below. So it'll be down here. What is the value of x in simplest form? Okay, now remember, we're on the unit circle. So we have a radius, or a unit circle has a radius of 1. So this would be the point 1, 0. Again, this would be the point 0, 1. This would be the point negative 1, 0. And this would be the point 0, negative 1. Okay, now they're giving us P. And they're telling us that P is x comma negative 5, 6. Okay, so what you're going to do is draw a triangle. Draw the line out to the point, and then draw the perpendicular up to the x-axis, just like you did in Friday's stuff. Always make your triangle to the x-axis. Okay, now we don't know x. That would be this value. Remember, you're starting at the origin, 0, 0. But we know that this is negative 5, 6. Okay, so what we've got is, and we know we're on the unit circle, so the hypotenuse is 1. So we know what we have is x squared plus this side, negative 5, 6 squared, equals the hypotenuse 1 squared. So we have x squared plus, okay, now a negative times a negative is a positive. 5 squared is 25. 6 squared is 36. 1 squared is 1. Okay, now I'm going to subtract 25 over 36. So I have x squared equals, okay, off to the side, 1 minus 25 over 36. Well, let's get a common denominator. 36 over 36, oops, not equals, minus 25 over 36, because 36 over 36 is 1. So 36 minus 25 is 11. So that's 11 over 36. So x squared is 11 over 36. Now I'm going to take the square root. Now x equals plus or minus the square root of 11 over, okay, so this is root 11 over root 36. The square root of 36 is 6. Root 11 cannot be simplified. Now I have to look back at my triangle and figure out what x is. Is x going to be positive or negative? Well, since I'm over here in quadrant 3, I know that x is negative and y is negative. So I'm going to choose the negative. So x is the negative, and put this in parentheses, square root of 11, and then hit your divide by key, and then divided by 6, and that will be your answer for x. Okay, now it has to be less than 1, because think about it, if you've got, let me blow up this triangle here. Okay, this triangle blown up looks like this. Okay, here's our unit circle part. Okay, this is a radius of 1. So our hypotenuse is 1 because that's the radius. This is negative square root of 11 over 6, and this is negative 5/6. So to get to this point P, the coordinates are negative root 11 over 6 and then negative 5/6. Both of those values has to be less than 1 because 1 is the longest side in any right triangle. So we just found P to be negative root 11 over 6, comma, negative 5/6. Okay? So that's what you're going to practice. So again, it's more practice with the Pythagorean theorem. Here I'm using the Pythagorean theorem. Okay, let's do another one. Okay, the point P, root 13 over 7 comma y, lies on the unit circle. Find the value of y. Alrighty. Well, let's just do that. And in fact, I'm pulling it right off of one of the problems on Delta Math. I'll show it to you. I'm pulling it right off of here. Okay. So in fact, let me just scroll a little bit so you can see. I don't want to lose my recording. Ah, there it is. Okay. There we go. So it says, find coordinate on unit circle. So we're going to do this one. The point P, root 13 over 7 comma y, lies on the unit circle shown below. What is the value of y in simplest form? Okay, let's work this problem out. So we've got, I'm going to draw this one a little bit bigger so it shows up better. So we're on the unit circle. And here's P. And they tell us it's root 13 over 7, comma, y. So I'm going to first draw from the origin to that point. Okay, now I'm going to draw a right triangle. Always draw the triangle to the x-axis. Okay, now, root 13 over 7 is my x-coordinate. So from here to here, it's root 13 over 7. What we don't know is y. Okay, guys, it's simply like this. If we were to name this point, we would name this 2, negative 3, because you go over 2, down 3. Okay, we're doing the same thing here. We're going over root 13 over 7, and then we're going down. We have to figure that out. We have to figure out y. Now we can, because we know the hypotenuse is 1, because we're on the unit circle. So we know the hypotenuse is 1. Okay, now let's use the Pythagorean theorem. So I have one leg, root 13 over 7 squared, plus the other leg, y squared, equals the hypotenuse, 1 squared. Now let's square top and bottom. So root 13 times root 13 is just going to be 13. 7 times 7 is 49, plus y squared equals, well, 1 squared is 1. So now let's subtract 13 over 49. So y squared equals, well, let's see, I'm doing 1 minus 13 over 49. So that's 49 over 49 minus 13 over 49. Okay, 49 minus 13. 9 minus 3 is 6. 4 minus 1 is 3. So that's 36 over 49. So y squared is 36 over 49. Now that's pretty nice. They gave us perfect squares. Okay, so that's nice. They gave us a perfect square. So again, it's going to be, let's move this so you can see it. Y equals plus or minus, the square root of 36 is 6, and the square root of 49 is, gosh, I almost wrote 49 again. The square root of 49 is 7. So we have plus or minus 6 sevenths. Now let's look back at our triangle, and we can see that we're going positive for the x, negative for the y. So y has to be a negative again in this case. So we're going to choose y equals negative 6 sevenths. And that will be our answer. So what we found is that this point P has the coordinates positive root 13 over 7, comma, and then y is negative 6 sevenths. So negative 6 sevenths. Okay, so those are the coordinates, and that's the answer for y, what we were asked to find right there, y. Okay, that takes care of it. I'm thinking 10 problems should do it. 10 or 12. You know what? Let's just go 12. You guys are good. You guys are good at doing this stuff. Let's just do 12 problems in the Delta Math. And okay, you know what? I'll go 10. Let's do 10 problems in Melta Math, in Delta Math, and we'll call it. So that'll be it. Okay, thanks everybody. Bye-bye.